Hi, so this is continuing from that first video. We're looking at this exercise. This is where I got the equation. I'm gonna do 2b, that we're going to sketch this graph, and then they want a minimum of 5 points. So we already checked Desmos on what it's gonna look like. Let's actually try to get these points. So when I look at this equation in vertex form, the most important point that I can get from this is the vertex. So let's obtain those values from H and K. This is in vertex form. So when I look at these two, I know my vertex coordinates is now going to be +1 and 3. So my graph moves 1 to the right, and it's going to move 3 units down. If I want to get corresponding points that go along with this, I can sketch this vertex first, and then it'll give me an idea of what points would be y's to obtain for x, so I can get the corresponding value for y. So right now my graph, if I do just a quick sketch, and I sketch the vertex, I know that this point at -1 and -3, so this is x is 1, this is y is 1, 2, 3, is going to be somewhere here. So when I sketch this graph, I could try to get the x-intercepts, I could try to get a y-intercept. So that's an additional 3 points, and then I would be able to get just a value that is symmetrical if I have the axis of symmetry as well. So I can draw my axis of symmetry here. So I know which points that I could obtain. So algebraically, I would try to find maybe the y-intercept, just because I can see that if it's opening up like this, it's a point for sure that I can obtain when x is equal to 0. So let's try to find that one. So let's write here. If I want the y-intercept, I'm going to say let x is equal to 0. So in my equation, I'll substitute that. I'll have y is equal to half. Anywhere that I saw x up here, I'm going to input 0 instead. So I'll have 0 minus 1 squared, and then subtract 3. So I just have to apply BEDMAS. So brackets, I have 0 minus 1. That's going to be -1. If I square it, it'll be +1. So this is +1, and we're multiplying it by a half. So that's going to stay the same. And then I'm going to subtract this by 3. So here you can just input this on your calculator, or you can try to do a common denominator. So this would be multiplied. This has a denominator of 1. If I want a common denominator, I have to multiply this by 2/2. So this one is going to be a half. This is 6/2. So now I'm going to get -5/2 as the y-intercept. And again, if you tried this on your calculator, this would equal to -2.5. So let's confirm. If I take my calculator and I type in a half, and I'm subtracting this by 3, I get this fractional answer, but you can change it, and here you can see that I'm getting 2.5 negative. So I can plot the y-intercept as an additional point. So my y-intercept point is going to be 0 and -2.5. So on my graph, when I plot it up here, this is -3, this would be -2. So I'm just going to plot an additional value over here. Let me plot it in a different color. So this point should read as 0, and this is -2.5. So symmetrically, if this is 0 and -2.5, and this is 1 unit from the x-axis, technically I should be able to plot a point here. So if this is 1 unit on the left, that's 0. 1 unit on the right from x should be x is equal to 2. So if I try to plot a value at x is equal to 2, I should actually get the same value here for the y. So let's test it again. So if I were to check another point, I would literally substitute, instead of 0 here, I would substitute x is equal to 2. So let's try that. So x is equal to 2. I'm going to just write it here on the side. Y is equal to a half. And this would be 2 minus 1 squared minus 3. So again, 2 minus 1 is going to give us positive 1. Positive 1 squared is just going to be 1 as well. So this is going to be the same idea, that this is 1. I'm going to multiply this 1 by a half. I'm still going to get a half minus 3. And then this is the same algebra that we did here. So I know that the answer is going to be the same, but instead at 0, it's now going to be at 2 and negative 2.5. So this would still be negative 2.5. And then my other corresponding point is going to read as 2 and negative 2.5. So here, when I try to graph this up here in the parabola, x is equal to 2 and 2.5 is over here. So I have like the beginning bottom portion of my parabola that's opening up, and now I need an additional 2 points. So if I wanted to do 2 points, I could easily substitute like x is equal to 3, x is equal to negative 1 algebraically. I can show you how to find y-intercepts again, just so that we're practicing. So let's try here. If I wanted to find the y-intercepts, sorry, x-intercepts. So let's write our equation. Y is equal to half x minus 1 squared minus 3. So if I want the x-intercepts, remember I'm going to say let y equal to 0. So I would have an equation that looked like this. That this y up here, I'm saying that it's going to be equal to 0, so I can isolate for x. So this is now reverse operations. I'm going to move everything over to isolate for the x. And I'm just going to do, yes, reverse operations for this. So if this is being subtracted by 3, I'm going to add 3 first. So this is going to be positive 3 half x minus 1 squared. And this term goes away. This is being multiplied. So what is the opposite of that? It's going to be divide. So instead of multiplying by a half, I'm going to divide half by both sides. And this is not 3 divided by 2, this is 3 divided by half. So this actually becomes 6. This cancels, and this is now x minus 1 squared. So here I have an exponent, and it's being squared. What's the opposite of squaring? I'm going to obtain the square root. So let's find the square root of 6. You're going to get a decimal number for this. So this is x minus 1, and I have the square root of 6. I'm actually going to leave it like this first. And remember, anytime that you square root a number, you always have 2 answers. One's going to be positive and one's going to be negative. And then over here, for the last part to isolate for x, it's being subtracted by 1. So let's add 1 to both sides. So I'm actually going to have 2 answers, which is expected. This is the parabola that opens up on the x-axis, so I should have 2 answers for that. So I'll have x is equal to the square root plus or minus of 6 plus 1. So our 2 answers are going to read as x1 is equal to positive root 6 plus 1. And I'm going to have x2, this is going to be negative root 6 plus 1. So let's check what these numbers actually represent in terms of a decimal so that I can plot it on decimals. So my x-intercepts, I'll just take my calculator. I'll take the positive root of 6. I'm going to add 1. And it gives me this number of 3.449. So I'll just write approximately 3.4. And if I take the negative root, so I'll do negative root 6, and I'm going to add 1. This reads as negative 1.4. So I can now plot these points as my x-intercepts. I'll go back to this graph. And I had positive 3.4. So this is positive 3, this is positive 4. So 3.4 is somewhere over here. And then I had negative 1.4. So this is 0, negative 1, negative 2. And here would be the other point. So here my SketchUp graph would look something like this. Hopefully you're using graph paper, but I mean a sketch, I always like a sketch. You're not too fussy about it as long as everything's kind of legible. I usually give you a minimum of plotting 3 points. We'll stick to that. This is just to ensure that we have a more accurate graph with the 5 points. And then remember, you're always labeling. So my axis is labeled. This green transform parabola, I'm going to make sure that I write the equation beside it. Y is equal to half x minus 1 squared minus 3. And then I want to check Desmos that I actually got all of these points correct. So let's check our work. It was already previously plotted with the first video. I'll bring it back up. So this is what our graph looked like. I already inputted the equation here. And then let's check our points. So here I have the vertex at 1 and 3, which was given to us from the equation. I have x-intercepts that you can see here at negative 1.4 and positive 3.4. And then the y-intercept is plotted here at 0 and negative 2.5. And then that fifth point would be the symmetrical point over here. So if I plot that point that I had, actually, let's not plot it. Let's check to see that if x is equal to 2, which was on the other side, I can see, let's not make both of these red. Can you change the color, please? Make it a line. I can see here that this point over here is the same y value over here for my y-intercept. So those are some strategies that you can have to find the x-intercepts. The vertex is clearly given to us, a y-intercept, and then you can find the corresponding point that's there. Okay. Let's try to highlight all of them if we could. There they are.